Hello everyone, my name is Manuele and I'm working on a game called Outer Space War Gears. This is the first technical devlog where I want to share some of the implementation techniques I've used in my game. I want to start from something that I think many people will find interesting, and that is how I implemented and optimized projectiles in my game. I don't say bullets because bullets are technically a type of projectile, the solid metal one, but there can be many different types of them, and my system supports different types of projectile. For my game I'm using the Godot game engine, so everything I say assumes some knowledge of the engine. I want to start by listing some of the features of my projectile system. This one is that all projectiles are nodes in the scene tree. That's because I want to be able to easily add different type of nodes to the projectile. For instance, I might want to add a light to a plasma projectile or a particle system to a different kind of projectile. The second one is that I want to be able to easily switch between physically simulated projectiles and raycasted only projectiles. The last feature I want to mention is that I want projectiles to optionally expand as they move. I use this to simulate plausible plasma railgun shots, but it could be used to simulate a shotgun too. To achieve this, I have that the projectile class extends the rigid body class, so every projectile is actually a rigid body. But for the ones I don't want to process collisions for, I just disable all collision layers for the rigid body. Whether or not the projectile has collisions enabled, I raycast from the previous position to the current position at each frame. That's because I want to make sure that I detect objects and not damage without using continuous collision detection. For expanding projectiles, I just shoot many rays arranged in a cone. Let's talk about optimizations. The first important one is pooling. When you instantiate a scene in Godot that has a rigid body and a mesh instance node, there's quite a bit going on in the engine. One thing is that of course memory for the nodes has to be allocated and initialized, but there is more. Because the rendering engine and the physics engine, or servers as they are called in Godot, have their own representation of the scene, multiple objects have to be allocated and initialized in those engines too. To avoid all this work from happening whenever a projectile is fired, populate a pool of projectiles when the level is loaded. Whenever I need to fire a new projectile, I take one of them from the pool and add it to the scene. However, adding and removing nodes to the scene tree has its costs. This is because callbacks have to be triggered and data structure modified every time this happens. To gain some further performance, I don't immediately remove projectiles after they hit something or they are out of range. Instead, I mark them as inactive with a flag so they don't actually update and make them invisible. I keep a list of these inactive projectiles in the scene tree. Whenever I have to fire a new projectile, I first look in the list to see if there is an inactive projectile in the scene tree. If there is, I just set the correct position and velocity on the projectile and activate it again. The last optimization I want to talk about in this video is parallelism. Keep in mind that what I say only works with the bullet physics engine. Also keep in mind that currently using GGNative on multiple threads is broken. I have created a PR with the fix that will be probably merged by 3.5. Instead of performing raycasts in the physics step of each projectile, I have that each projectile has a task object that can perform the raycast. Tasks are executed in a thread pool when a specific node is updated. Because it's only safe to raycast when the physics engine's data is not being modified, I block the main thread while the raycasts are being performed. Let's talk about the results. I have created a benchmark, and without any optimization except for the code being written in C++, the game engine can handle a maximum of around 500 projectiles without any performance degradation on my machine. After activating all the optimizations I mentioned, the game engine can handle a maximum of around 900 projectiles before I get performance degradation. That represents a performance gain of around 80%. Not bad. That's all for this devlog. If you like this kind of content, please like and subscribe. Also appreciate any feedback in the comment section. See you next time.